Welcome to the Rise Inside podcast, hosted by Justin Starbird and powered by Rise Robotics. Listen as host Justin talks to experts from the Rise team about topics relating to mechanical engineering, industrial design, commercialization, and innovation. True collaborations work when ideas are integrated at inception to solve significant problems. Rise Inside brings together how the team continues to work with great folks to commercialize ideas. You're listening to the Rise Inside podcast. Here's your host, Justin Starbird.
Welcome back to Rise Inside. My name is Justin Starbird, and today I'm joined by Kyle Dell'Aquila, co-founder and creative director, and Ken Gray, the vice president of business development. Guys, welcome back to Rise Inside. How are you today?
Good. Thanks for having us.
Yeah. Now, Ken, this is you're our first two-time guest, so this is really exciting.
I'm honored. I couldn't be prouder.
Kyle, I've had the fortunate opportunity to speak with the other co-founders prior to having you on today. Tell me a little bit about your role here at Rise.
Yeah. So. My role has always been wearing the hats of everything else that's not CEO related or mechanical engineering, which pretty much everyone else is. So I have been helping out with a lot of the business development before Ken showed up. I'm still helping. Now it's a bigger team on the soft skills.
He's definitely my right hand, Justin, to say the very least.
Yeah, and I'm okay with that. Whatever gets the job done. And business development is a very strange and squishy subject, and it's not for the faint of heart.
So he always does this. So Kyle underrepresents himself. Kyle is one of these rare engineers who is equally strong left brain, right brain, and so he's a tremendous combination of artist and technical person at the same time. So a lot of the creative things that you see on our website, for example, and a lot of the incredible designs start off as impossible ideas in the mind of this person, and find themselves into production and in many products that we build. So I think he's always too modest. So I had to jump in there and say that.
Well, thank you for that overview of his role. Kyle, you and I have got to know each other a little bit over the last few months. Same with you. Ken and I go back years. So this is like old hat. But, Kyle, tell me a little bit about, Rise. What does Rise do?
Yeah. So it's morphed over the years, but I would say the common thread that was always there was, at least when I showed up, was actuation. And I showed up in, I think, 2015, late 2014, 2015. That's a number to clarify, but it's been around. I've been here since what we used to call the cyclone days, and that's when our actuators were 3D printed and we were using string or rope. And I was working at prior to Rise, I was working in Fall River, Massachusetts, at a printing and dyeing manufacturer, doing a lot of military stuff, a lot of camouflage. One of the 3 printing and dyeing manufacturers that does all the camouflage for the U.S. military. And one day, Aaron reaches out saying that some of my roommates who were trying to do a startup, who were consulting Aaron's, Aaron wanted to do a trade instead of money in repay for advice, and Aaron was looking out for somebody that can do a lot of a variety of tasks that are not mechanical engineering related, including marketing and visualizing, and so I came over. I drove up one day to see what this was all about. I didn't exactly know what he was talking about. I didn't really have in my mind that it was about actuation, but when I showed up, he toured me around the Greentown lab and showed me this object, this plastic device that looked, kind of delicate, but I finally understood what it did. It contracted a very short amount of stroke, over 4 inches. And it took me about, 40 seconds to figure out that it was very strong. Pulled about like 70 pounds. And so obviously that's a lot stronger than your arms. And it was driven by some very, very simple, I think it was like an RC gun remote, like a, toys. It was driven by a simple remote, and you would hold it and it would pull your arms in quite a bit. And no matter how hard you tried, it was obviously stronger than you. And I'm like, wow, I haven't seen this. I have seen actuators before, and they looked kludgy and complex, but it was kind of stunning to me that, with so little, such a lightweight object, could you drive something so powerful that it would dominate your arms. I know that's not really a figure of merit or anything, but I immediately had the picture in my mind that this could be an industrial something someday. And my profession, or I went to school for industrial design, and so I couldn't help but mentally slap the word industrial on it, and I'm like, this is gonna be great. This is gonna go into really big equipment someday. And it kind of has been since. It's always been actuation. But prior to the cyclone, Blake and Aaron were initially trying to shoot after exoskeletons and exosuits.
Mm-hmm. Yep.
And when they explained that to me and showed me a little bit of the componentry they were building to augment one of the earliest investors, Bill Warner, who could use some man amplifying equipment, I thought it was really a noble cause. And I think it sold me right away when Aaron mentioned the word catapult pants. He's like, wouldn't it be great one day to wear a piece of machinery around like pants that would actually launch you, like the feeling of sitting on a catapult? I'm like, wow, I haven't seen anything like that. If you guys think it's possible, well, nobody else had shared that kind of a vision before, aside from what you might see on movies.
Right.
And that was powerful. I love it. I love the idea of the man amplifying idea.
Mm-hmm.
But it, at that time, the component was the critical ingredient. And so it was just refining that machine that contracts. A lot of the early designs were pull only. And pretty much right away, I think it was in the first month, we were demonstrating this little product at the MIT hackathon. We're seeing what other kids would do to make use of this machine. This one group made an exoskeleton arm, just an arm out of angle iron and stuff. It was very crude, but it was really cooking a whole bunch of sort of ideas, like how quick it was for this one team to take our component and hook it up to very crude looking appliances and make it lift a very heavy object. And I'm like, wow, this is like what you would see in movies. This is it. I haven't seen another company that was shooting after such a tremendous feeling. So, and it only got stronger and stronger, what was the other part of the question?
No, that's perfect.
That's a great story. He's never told me that story before, Justin. Is that do we still have that thing in the lab? We'll come back to that later. But I want to see this. I want to see that plastic device at some point too. I haven't seen that.
That's awesome.
It is in the lab. Yeah, the very, very first rendition of that device is in a body bag, and it is in all sorts of bits and pieces. But the Cyclone, as I knew it, is still alive. I mean, some of the strings are all kind of gnarled together, but it's there.
Yeah.
It will spin if you plugged it in. It's crazy. It's part of our awesome history lesson that's sitting on the catwalk upstairs,
which I did get to see. So
nice.
So I'm familiar. So that's pretty awesome. I mean, looking back and seeing how far you've come, where is Rise today? What are you doing today?
Yeah.
Or a better question is maybe, what is Rise today?
What is Rise today? Well, what Rise is today is we've got a component that will replace all the problems with hydraulic systems. It's more like pushing and pulling motion with hydraulics.
Mm-hmm.
We are not shooting after the rotary to rotary applications, for that is, in our minds, a somewhat solved problem. But to do rotary to linear, to go from like a prime mover to linear motion with as least amount of energy as possible, that's us. That is Rise. And there's not a lot of, for the sizes that we're shooting at, there's not a lot of competition. So we really are a great answer to an age-old problem, is knocking out the issues related to hydraulics. No more fluids. We kind of alluded to that may be where things would go long ago, and it scared us because man, the forces seen in hydraulics were pretty insurmountable at the time. We were always using the metric of cross-sectional power density as a metric. The amount of how many pounds per force can you do for a given cross section. That's how we were comparing ourselves to other appliances. And back in the string days, we were, man, magnitudes off. But now we are on the order of something you would see with these big fluid powered steel barrels. And yeah, we really are starting to be a force to be reckoned with, I would have to say.
Yeah, absolutely. And the more I get to know, the more I see that as well. And, right outside of your office is a construction site that's going on. And as I, told Tomas last week, not for anything, but, there's a day not in the too distant future where, Rise is inside a lot of the equipment that's moving earth and moving material right outside. And so, I've heard a little bit of this from Ken, and I'd like to get your insights, Ken, in a minute. But, Kyle, for you, what made this vision so important?
What made this vision so important? Which vision? There's quite a few. Well, there's probably two.
Yeah.
There's like exoskeletons, and then there's destroy hydraulics.
So
better.
Yeah. So the destroy, the exoskeleton was a more noble, cause, I think. And I think that's something based on the conversations with everybody that I've met, that it would be a great opportunity to come back to. And then in the meantime, you have this destroy hydraulics, as you say, as a true vision, and somebody
you're going to make some big companies hate us with that.
No. This will be our title today's
fine.
interview: Destroy Hydraulics.
New monarch of machines.
That's
destroys
right.
hydraulics.
So why is it? Why is an alternative to hydraulics so important to you, Kyle? I mean, it really is. I mean, this is really what you're about.
Yeah. Well, early on when we were in more of a fantasy land. Oh, and something I forgot to point out about the exoskeletons, is that the previous attempts in this space are, in the commercial space, which has predominantly been in the medical space, are too slow, too boring. And the military versions of exoskeletons at that time were definitely powerful, and you can lift heavy things, but they looked like you're wearing a car, super heavy. And those giant machine versions of the same thing would have to be hooked up to an umbilical, like, to power it. You couldn't carry your own gas engine on board that walking machine. So usually they're tethered, or they look
like Sigourney Weaver in Alien, if you remember the 80s movie that scared me to death. But they're big and bulky, actually bulkier than that in a lot of ways.
Yeah. And we realized it's an issue of components. We knew that the current state of the art with the commercial stuff, if you wanted to carry your own power supply, you'd probably have to use, a lot of people are using like mini winches or just simple motors at the joints, and they're just insanely slow. The only thing that those commercial versions would augment are people who had no power in the legs. It would be able to make somebody who couldn't move be able to move at crawling speed. It's very not exciting. And we, like our vision, we wanted athletic exosuits. That's why we call them exosuits, not exoskeletons. We want them to be fun things that, one day would augment the Olympian to become a greater Olympian without having to take steroids. Like you would be able to put on an appliance and then leap a few yards on a track on a football field. And that was kind of like a very early vision that Blake and Aaron had, as well as Tomas. They're all very athletic fellows, and they didn't want to work on boring things. I think we all shared the same sentiment about how boring the medical space is, and why can't the toys work for the most of us? Why can't the man be empowered? And as we were learning about the component space, there was a great divide between those gear-driven designs and then this fluid-powered world, and just an enormous gap in between. And there was something about actuation that we just couldn't help ourselves. So that's where we funneled our energy. There was a moment there before that where they thought it was an issue of springs not being power dense enough. And there was some amazing designs in making springs more power dense. And they're using fiberglass diamonds that were all rigged in a very amazing, compact, modular, grid-like fashion, and something that would weigh, compared to like a car coil spring, you can have something in the 10th of the weight or even less in a small form factor. But Blake and Aaron realized that, when it comes to energetic fun equipment, it's not the spring's problem. It's how much power you can put into a spring. The spring is just a passive component, but you need to convert energy into this linear motion that can, parallel your legs per se. And that's why actuation was so important. So
with that, I'm sorry, go ahead, keep going.
Oh, no, I was going to ask for where did I lose track? What was the question?
Yeah, you stayed on it.
Yeah, that was perfect.
That's a great story. You've never told me that story. I mean, how much time have I spent with you? And I've never heard that perspective before. You've been holding out on me.
You put a microphone. You put a microphone in front of somebody, and all of a sudden,
fantastic.
Yeah.
It really.
So like rewinding the tapes. Yeah.
So it's so it was the bulk. It was the bulk of hydraulics, and the limitations of, traditional, linear actuators that drove you guys, that drove this brilliant team at Rise to develop something that was something that was electric, that had much more capacity and capability than electric actuators.
Yeah.
To deliver the performance of hydraulics, that is the force, the speed, the stroke, without the bulk, right?
Yeah.
And that's what drove this business, the creation of Rise Cylinder, right? Am I paraphrasing that right? I think that's a really interesting point, really interesting way to tell that story, Kyle. I love that story. Thank you. Thanks for sharing that with me after all this time. I mean, you've been holding on me, dude.
I thought it was obvious. I don't know. Thought somebody said it. Maybe like over the years we've like shied away from like the useful whimsy, I think is what Blake would use as a word. Our explorations in the exoskeletons was something that really fueled our energy. We really, it's like we were creating a new market. It's like, it's not for medical, it's not for military, it's for athletic stuff. And creating a new market is like one of the hardest things you could possibly do. And we always had that in the back of our mind. And our components were not good enough to be in that space. But, as we were studying the actuator, as it advanced, as the pounds per square inch of the cross-sectional area increased over the years, it would start to bring about ways in which we can compare it to some existing component. And just kind of getting intimate with at this force, it's 70 pounds moving at this stroke, we really are like that kind of a screw. but they last longer than we do. But, or like, in like every evolution of the design, there would be something in the real world that it would compare to. And yeah, and it's like this soup is too hot, this soup is too cold, and like, maybe we can make money with that thing we can compare against. And we're all I think one thing that we are as a company kind of have been kind of unique, and I don't know enough companies to know this exactly how this compares, but we've always had a very we're always fundraising in very lean amounts. We've been on angel investment for quite a good amount of time, and we didn't want to ratchet up. We didn't want to borrow a whole bunch of money until we really knew we were shooting after a real problem. So we've been, I think one of the investors, what was his name? One of the.
It's okay. It's okay to leave an investor nameless.
Oh, okay.
It's all right.
Yeah. Well, we over the years, I would say like 2016. I think it's when we went to the launch festival. We were doing the rounds with like checking out investors in the California space, and this one was asking us of our story, and then at the end of our story, he's like, "Man, you guys are cockroaches. You guys should be dead by now. Like, I don't understand how you haven't found a market and you're still alive today and you're still asking for money." It's like, well, we're persevering. We're trying to be as lean as possible the whole way through. We know there's something here, And
that is an interesting philosophy, Justin, we haven't talked about, but when Rise does seek investors, it seeks an absolute minimum. It seeks an absolute minimum every time. I mean, philosophically, the approach is seek no more investment than absolutely required to get to that next objective, to get to that next level, toward an independently viable business. It's an interesting approach. It's not, we're not going to go out and find and get $100 million and figure out how to spend it. We're going to go seek, a small amount of funding to get us, to this next breakthrough, and we'll find partners along the way that want to use the technology. That's philosophically how they've worked.
Yeah,
and
it's lean.
Yeah, no, and a lot of that has happened right in your own labs, right? All of the work, and you've had some partners. We're going to speak to one here at another time, but yeah, Kyle, tell me a little bit about one of the breakthroughs, or I guess I was corrected. It was not a mistake, but as you learned more about not just the cables, or in this case belts, and noticing where they were tiring out. But what was the breakthrough that really led to this next level? Where I've heard it from, Tomas, I've heard it from Blake, I've heard it from Aaron, but tell me from your perspective, especially coming from specifically industrial design, everything that you'd learned. Tell me a little bit about, that breakthrough.
Yeah. So so I'll quickly speak to the evolution. So when I showed up and I was looking at that little toy, at the time the innovation was this thing that we called a conical windlass, and eventually that evolved in away from the conical shape into the classical windlass, where you have two drum diameters. And what we were doing is at that time, I think at that time we were starting to compare or test against, we're using air compression as the means to stress test our linear actuator. So we took like a normal windlass, and at that time we started to get into belts. And so we would have to wrap a belt around these drums helically, and they would have to exit the drum and do 90-degree turns and move about like bunny ears, so that way the carriage would move in line with the whole arrangement. And so we were putting some pretty significant twists to get the belt to go 90 degrees, like a mule drive, to make very strange 90-degree turns, and it would have twists at all points. But we did notice that the shortest length the least ideal zone for the belt, where the twist is the most severe, was presenting some sort of a problem. And as we would cycle test these things, I was noticing that one edge of the belt would kind of be climbing up, kind of like squeezing up, and it would get destroyed on one edge of the belt. And actually what I really noticed was like a pile of burnt rubber, just kind of like just debris underneath the rotor, indicating that there's some sort of abrasion or something occurring, just leaving little indicators of wear underneath on the table. And then, I was like, that's interesting. And then Aaron and I were staring at it, and I was just kind of joking. It's like, man, is there some sort of a way where you can is there a way where you can compensate this, that edge that was showing all sorts of destruction? I think it would even reveal exposed belt after a certain amount of time. But at the time I was joking, maybe could the surfaces of the rotor be skewed in a way, so that way it would force the belt to track away from the edge that it was wrecking against. And then Aaron and I were just kind of spitballing. I can't really remember the details, but Blake came over and was like, math, and then proposed an interesting thought process along those lines. I can't remember that. That's all Blake's head over there. I don't know what was going on.
So
but
yeah, so this
after.
I've said this to you before, Justin. This is the intersection of elegant mathematics and practical applications. And Blake's corrected the word I use often, so I'll use it correctly this time. But there are two ways. There are two ways to kill a belt. One of them is to twist it when it's rolling, when it's moving. The other is to fleet it. So you bend it about around an axis that's perpendicular to the plane of the belt, and those two things will just destroy the life of a belt. But it turns out that if you twist and fleet at the same time at the right ratio, you can actually improve the life of the belt, or I should say improve it. It's going to wear out eventually, but you're going to get extraordinary, unexpected life from the belt. And that mathematics, that's really from the mind of Blake, which is unbelievable, from our chief technology officer. That forms the basis of many of the patents that are at the heart of Rise technology and Rise cylinder.
Yeah. So two wrongs made a right.
Yeah.
Yeah. I almost kind of view it as
exactly right.
Yeah. I almost view it as like on car steering, how you have like toe and camber and all that. There's some combination where the wear is reasonable and the car tracks forward, and but if any of those compensations are out of whack, the car will drift, or it'll be like rolling down the road diagonally. It feels almost like when it first came about, when Blake revealed that thought principle, that was kind of going in my head, because I during school I was working on on a vehicle, a two-person folding bike, I guess you could say, and that's where I learned about suspension and all that subtlety. And it's subtle.
Interesting, because when I first saw the mathematics, I thought of a high banked oval racetrack.
Oh.
It's the same kind of idea where you're rolling, you dive into a curve, and the bank of the track relieves the stress, right?
Mm-hmm.
Relieves stress to a point, and you find an equilibrium, which is, or even on highways in this country that are there, where the exit ramps are banked and those sorts of things. It's that same kind of feeling where you can't twist it, you can't fleet it, but if you do it at the same time at the right ratio, then you've got this perfect dissipation of stress that allows you to maximize life. And that's really at the heart of this technology.
Yeah.
And today that technology is lending itself to potentially solve, problems in a whole host of industries. Ken, maybe you jump in and tell me a little bit about, the first industry that Rise is really going to tackle.
Yeah, we want to walk before we run, I guess. And the applications that Rise Cylinder does extremely well, and does many of them. But the first one is lifting and placing applications, and so any material handling, forklifts, those sorts of things. But perhaps the best application for Rise technology is a power lift gate, and that's the product that we're going to commercialize with a company that many people know called Anthony. And Anthony is the original inventor of the power lift gate for Class 8 trucks and that type of last mile delivery. And basically, a power lift gate is a device that if you've loaded a truck at a loading dock and you have to deliver something heavy object to a location without a loading dock. Let's say they're going to deliver, the kitchen appliances to my home. In fact, they did that here not too long ago, and they used a power lift gate, and the lift gate simply lowers it to the ground so they can get it on a dolly and roll it up to the front door. Well, what's really cool about Rise in that application is that the motor that we use to lift an object into the back of the truck, we actually turn that motor around and run it as a generator when we set the object down on the ground from the truck, and that generates power. And one of the big problems with lift gates, with hydraulically powered lift gates, is they use a lot of power. And one of the failure modes that drives shippers nuts is they get to a site and the lift gate won't work because the battery's dead. And the Rise technology in that application just frankly prevents that from happening, and because we're generating power, recharging the battery as we go. So that's the first product we're going to go really to make commercially available at the battery show, September 14th, Novi, Michigan. Be there with us, and we'll show off some more stuff.
And Kyle, how does that fit within, the vision that the founders kind of laid out, I wouldn't say years ago, but, I know Ken is more recent to this, and these are newer areas of opportunity, but, how does that fit within, the vision that was set and the mission that you guys are on?
Well, we've always had the idea of fun fueling industry. I think for quite a while, a story Aaron would always tell is, the deeper story behind Henry Ford and the commercialization of the automobile. And Henry Ford failed twice, failed two different companies when he left Edison's lab. Henry Ford was trying to commercialize his motor, his utility machine, the thing that would produce power at the end of a shaft. I think, if I recall correctly, it was he first tried selling the motor as itself as a component. Didn't really work. The second time around, he was trying to sell an all-utility tractor that would do everything under the sun. Everything agriculture. It could cut grass and stuff, and it just didn't sell. And then the third time around, he's like, let's just race these things around on a cart. Let's just do the Henry Ford sweepstakes. And for some odd reason, that caught like wildfire, and that's when the industry realized the importance of the automobile. And so jumping over into our world, it's the vision is man amplifying clothing, and it's going to take a lot to get to that point where it doesn't hurt anybody. It's easy to make. It's very affordable. The common athletic person could afford such a thing. And that road is so long that we kind of knew that we would have to commercialize the key ingredients that would make that application work. We would have to commercialize the components. If it was so darn good, we'd have to commercialize it into today's problems, into today's real world industrial problems. And you want to pick an application that is easy to achieve, given that given what you demonstrate today. You want to go into an application that you would satisfy right away in terms of cycle life and force and speed. It would be a great equivalent, a no-brainer drop in. So we've been pretty. We've ultimately, of all the things that we were skating around, there's all sorts of appliances that need pushing and pulling. And the one that resonated the most at the time was lift gates. The big business problem is that these trucks out there on the field, needed to, well, one of the big things that's going on in cities across the U.S. is the no idling laws. A lot of these trucks are a thing to blame as far as pollution and air quality. So they've been putting up these, these little laws saying that you can't leave your truck idling when you're delivering goods in the cities or districts or whatever. And then now you're probably wondering why would that matter? I mean, everyone should turn off the truck and don't be a bonehead and leave your car while it's unlocked, kind of a thing.
Sounds simple. Sounds obvious. Yeah.
Sounds obvious, right? Well, it turns out that if you don't idle your truck, it makes it hard to turn back on. Well, why is that? Well, for a lot of these trucks that have big appliances, either like refrigeration units or lift gates, more often than not, the truck driver will not be able to turn on his truck because the little poor 12-volt batteries that sit in there are drained beyond the ability for the truck to turn over again, which
especially when they have both. And if you have refrigeration, you have lift gate because you need to unload pallets. And so
big time. And those little alternators are just not good enough at putting the energy back over the course of like driving down the block 2 blocks. That is not enough time for you to replenish the batteries. And that in combination with the hydraulics have a tendency to just degrade in performance as it calendar ages or just as you use it. The nature of hydraulics pollutes itself, and the pollution of itself, the little metal particles swirl around in the big liquid bath and they get wedged in things. It ultimately means it gets less efficient. It draws more power. Yeah, just to do the same task over time, no matter what you do, it'll just become less efficient. So you either are, as a fleet maintenance, you should replace everything, like at least once a year, but people don't. So the motors that drive the hydraulics have to work harder and harder and harder. And so naturally, you're just going to be pulling so much energy from the batteries. There's nothing you could do. And it's really hard to diagnose when is it time to replace the fluid? When is it time to replace the valves, the hoses, the seals? It's people just go like, when it breaks, then we'll call in a technician. And like, that sucks because if you're a truck driver, you're out in the field and you can't turn on your truck and you got goods that have to be somewhere, you lose clients that way. So all the liftgate manufacturers are well aware of this problem. They all put up with it. They'll shrug your shoulders, and then you have the generic maintenance staff put up with it when it does happen. Very often you have to have another service truck to recharge the battery so they can get going. And it's a scenario where you're kind of blind, but you lose clients that way. And a little underdog company like Anthony, who did have the champion title at the time, who lost it to their competitors, is totally aware of this problem. And when we showed up and we started saying that we could solve some of those business problems where you may be losing customers to basic mechanics, like we could solve that. They pieced it together and they're like, yeah, this could really do a big thing for them. And they're hungry to get a competitive advantage against their competitors. And so it's kind of a no-brainer to them. But say if you're a number one player, the number one liftgate maker, you got most of the market share, and you probably don't care as much because the brand name works. So now we're going to see if technology can really knock the title champion off their feet.
It's a reinvention as well, Justin. I mean, it's Anthony was the original inventor of the power liftgate, and working with them, Rise is reinventing the Anthony liftgate, which is really kind of a cool. It's really a great story. I think, and I do. There's some real advantages here for Anthony and their customers, and a great opportunity for them to restore their position as market leaders. So we're very, we're just thrilled to be working with them, thrilled to be launching the product, and very excited, enthusiastic about it. Well, great stories, Kyle. I love it, man. I love the perspective. That's fantastic.
The future is certainly bright, and that's why I love the line Rise inside, right? Rise is going to be inside, some of these underdogs. I know we view ourselves as underdogs, and to your point, thinking about speaking to an investor 5 years ago, and they're like, "What are you doing?" And here we are 5 years later, really making a difference, still sticking around. I think that's a testament to your fortitude.
The cockroach is still alive. I can't
That's right.
believe it. 5 years
Yep.
later.
Yep.
That's great.
Yeah.
Well, I appreciate you both joining me today. It's been really great, hearing your perspective.
Hell yeah. Likewise. We should do this more often. It's not every day we can get the wide angle view of where did we come from. When you're in the day to day, you're just trying to shoot at the problems as they come. But it is really energizing to kind of reflect on how crazy of a harebrained idea this is. We'll be at Wired one day.
I can't wait to have you guys listen to each other talk about it too. It's gonna be pretty cool.
It's gonna be fun. Yeah, it'll be fun. It'll be fun to hear it. Thanks, Justin. I really appreciate the questions. Are terrific. You're bringing out some stories that I thought I already knew, and so thank you for this. It's been really fun.
Good deal. All right, guys. Thanks so much for joining me.
All right, Justin.
You have been listening to the Rise Inside podcast, presented by Rise Robotics. On behalf of our guest today and host Justin Starbird, thank you for listening. Please share your feedback on our LinkedIn page, linkedin.com/company/rise-robotics.